How to read and use steam tables. So in this topic, I will be discussing about the steam table and how we can read and use the steam table. So to read a steam table, it is important that we learn everything about it, such as the different symbols, units, and terms used in the table. This will help us understand the functions, purpose, or properties of this in the steam table to help us read and use it more effectively. So before we get there, let's first discuss about the basic terminology to help us understand the table. So let's start with P. So P is equal to the pressure of the steam or water. T is equal to the saturation point of steam or water. And Vf is equal to the specific volume of saturated water. Vg is equal to the specific volume of saturated steam. Hf is equal to the specific enthalpy of saturated water, and it is energy required to heat water from 0 degrees Celsius to or 32 degrees Fahrenheit to the boiling point. And HFG is equal to the latent heat of evaporation. It is energy required to transform saturated water into dry saturated steam. And Hg is equal to specific enthalpy of saturated steam. It is total energy required to generate steam from water at 0 degrees Celsius or 32 degrees Fahrenheit. So to understand this individually, let us begin with the saturation temperature. So the saturation temperature is the temperature for a corresponding pressure at which liquid boils into its vapor phase. So here we have an example diagram, and this line here is the constant pressure line, and this is at 1 atmospheric pressure. So the green dot is the saturated liquid state and the red dot is the saturated vapor state. So in this horizontal line, the fission process is taking place, and the temperature at saturated liquid state is the saturated temperature. So specifically for water, 100 degrees Celsius is the saturation temperature at 1 atm pressure. Now let's understand the saturation pressure. So the saturation pressure is the pressure at which a given liquid and its vapor can coexist in equilibrium at a given temperature. So here we have another example diagram, and all of these lines are the constant temperature lines. And the green dot and the red dot here are saturated liquid and saturated vapor, respectively. So pressure on that horizontal line is called saturation pressure when liquid and vapor can coexist together in equilibrium. And for water, 1 atm is the saturation pressure at temperature 100 degrees Celsius. Again, let's see another diagram when property A is on the x-axis. So there are two states that we see here, saturated liquid and saturated vapor. So from the convention, F is denoted for the saturated liquid and G is denoted for the saturated vapor. And here, AF is the property A at the state of saturated liquid state. And here, AG is the property A at the state of saturated vapor state. And AFG is the change in property A while changing phase from saturated liquid to saturated vapor. From the steam table, we can evaluate the thermodynamic properties like specific volume, internal energy, enthalpy, and entropy. So steam table can be of two types. First is saturated steam table and second is superheated steam table. And saturated steam table can be of two types as well: temperature-based steam table and pressure-based steam table. So a saturated steam table is an indispensable tool for any engineer working with steam. It's typically used to determine saturated steam temperature from steam pressure, or the opposite, pressure from saturated steam temperature. In addition to pressure and temperature, these tables usually include other related values such as specific enthalpy H and specific volume V. The data found in a saturated steam table always refers to steam at a particular saturation point, also known as the boiling point. This is the point where water and steam can coexist at the same temperature and pressure. Because H2O can either be liquid or gas at its saturation point, two sets of data are required: data for saturated liquid, which is typically marked with an F in subscript, and data for saturated gas, which is typically marked using a G in subscript. Superheated steam tables. So the values related to superheated steam table cannot be obtained through a regular saturated steam table, but rather require the use of a superheated steam table. This is because the temperature of superheated steam, unlike saturated steam, can vary considerably for a same pressure. In fact, the number of possible temperature-pressure combinations is so great that it would be virtually impossible to gather them all in a single table. As a result, a large number of superheated steam tables use representative pressure temperature values to form a summary table. Okay, now let's go ahead and see individually how to interpret data from a steam table. Okay, let's start with the temperature-based steam table. So this is how a temperature-based steam table look like. On the first column is the temperature on degrees Celsius, next is the pressure in bar, and this pressure is the saturated pressure corresponding with the given temperature. And next to it is the specific volume, internal energy, and enthalpy. And in every property, there are two columns, and that is VF, VG, UF, UG, HF, HG. So VF stands for the value of the given property at saturated liquid, and VG stands for the saturated vapor. And in this steam table, you have to begin at the row at the given temperature. Okay, let's understand this with the example problem. So we have here example problem number 1. What is the specific volume of saturated vapor at 40 degrees Celsius? So here we see that the temperature is already given, and we are going to find the specific volume at saturated vapor. So let's look at the column that indicates saturated vapor in specific volume, and we will get the answer. So the answer for this problem is 19.515 m cube per kilograms. Okay, let's have another problem. So what is the enthalpy of saturated liquid at 130 degrees Celsius? So as you can see, temperature is already given, and we need to find the enthalpy at saturated liquid state. So it is clear that the answer is 546.38 kilojoules per kilogram. That is the answer for problem number 2. Now let's go to the pressure-based steam table. So in a pressure-based steam table, on the first column, pressure in bar will be given, and next to it is the temperature in degrees Celsius. That temperature is the temperature corresponding to the given pressure, and next to it, you will see the specific volume, internal energy, and enthalpy. And same with temperature-based steam tables, it has two columns. To understand this, let's have an example. So to understand this, let's have an example. So what is the internal energy of saturated liquid at 70 bar pressure, and what is the saturation temperature? So to solve this problem, let's look at the row where pressure is at 70 bar. And we need to find the internal energy at saturated liquid state. So there we have it. It is clear the internal energy in UF is 1258.2. So the answer is 1258.2 kilojoules per kilogram. And the saturation temperature at 70 bar is 285.83 degrees Celsius. That is the answer for this problem. Now let's understand the superheated steam table. So the superheated steam table will look like this. So we can see that this table that we have here is only 0.01 megapascals at 45.81 degrees Celsius. The temperature is the saturation temperature. So in the first column, we will see the temperature, and in the second column, the specific volume. In the third column is the internal energy. In the fourth column is the enthalpy, and lastly, in the fifth column is the entropy. Now let's have an example problem. So determine the specific enthalpy of water at a state of P is equal to 0.01 megapascals and 400 degrees Celsius. So here temperature is given at 400 degrees Celsius. Now let's look at the row where temperature is 400 degrees Celsius. And we need to find the specific enthalpy. So the answer is 3489.7 kilojoules per kilogram. That is the answer for this problem. Okay, sir, that's all for this topic, and thank you for watching, and I hope you like the video.